Hello gentlemen, purpose of this video is to look at linear equations. I suspect that most of this should be reviewed for you, so I'm going to move through it rather quickly, and then there's some practice problems that you have at the end that should help you just refresh your memory on lines, perpendicular lines, parallel lines. But let's get this started. We're going to talk about equations of lines. We're going to see a couple different equations of lines. This one in particular right here is the slope-intercept. This is probably the most common one that you have used before. Y equals mx plus b, where m right here, right there is your slope, and b is your y-intercept. Just a couple of things. We talk about the slope of a line. Slope is in general just rise over run, or the change in y over the change in x. And so hopefully you've seen all of these equations right here, and these should look familiar to you. A couple things about slope. I want to draw a couple quick graphs here for you. A positive slope means you're going to have a line that's going to be something like that. Okay, this is m greater than 0. Okay, it's going to be rising like this. It's an increasing function. We'll talk more about that. If my slope was negative, I would get something like that. Okay, this is where m is less than 0. Two other situations that you need to be aware of is when m is 0, when we have a horizontal line. So if I have this situation, is my x and y axis. If I have like that, horizontal line, m is equal to 0. Such an equation would be something like y is equal to 3. Okay, that's a horizontal line, and the slope is 0. The other one is when we have a vertical line. I just want to cover that. If I have a vertical line like that, this would be something like x equals 2. Here, m is undefined. Okay, and look at the reason here. Look at the slope equation. Look at the bottom. If I have no change in x, if delta x is equal to 0, then I'm trying to divide by 0, and we know we can't do that. Okay, so understand, looking at a line, you should have, 4 basic cases. You have when the slope is greater than 0, less than 0, equal to 0, and a vertical line, it is undefined. Okay, so just should be a review there. Here are different types of equations of the lines. Here are the ones that we will use most often right here. I want you to pay particular attention to these two. This is slope-intercept right there, and this is point-slope. Either one is fine unless you're asked for a specific one. Here is equation of vertical line, x is equal to a, horizontal line, y is equal to b. Remember here, slope is undefined, and here slope is equal to 0. For horizontal line, slope is 0. Okay? I'll ask one question about this in an example coming up, but again, the most common ones are going to be these guys right here. Okay, make sure you know those two. Let's do this. Find the equation of a line connecting 2 points, 2, 4, 4, negative 4. And I want to write it in the different forms: standard form, point-slope form, and slope-intercept form. Well, the first thing I want to do here is to find the slope of the line. And again, I would tell you guys, pause video and try to do this yourself, and then check your answer with me. If I look at this and I do this, here, this is going to be my x2, oops, and y2 right there, and this is x1 and y1 right there. Okay, if I plug that in, again, be careful with your negative signs, and simplify, I'm going to get my slope is equal to negative 4. So now I already know my slope and I know a point, and so the easiest equation to go right to is my point-slope form. Okay, and I can pick either point. I can pick this point right here, okay, or I can pick the other one. And I'm going to get this, these are the same equations of the same line here, okay, as you'll see when we simplify. So there is the equation of the line in point-slope form. To go from point-slope to point-intercept, I just want to solve one of these, and I'm going to use this one. I'm going to solve this equation for y. So I distribute the negative 4, and then I'm going to bring the 4 over. Okay? If I do that, I get y equals negative 4x plus 12. and that's my slope-intercept. Okay. Now if I want to get to standard form, I got to bring everything to the other side. No fractions here, and then that's going to be my general form. Okay. Let's move forward. There's the equation of that line right there. That's what it looks like. Get rid of some of this. Okay, so let's keep moving on here. Let's talk about parallel lines. Parallel lines, two lines are parallel if and only if their slopes are the same. Okay, that's pretty straightforward. So this is an example of two parallel lines. Notice that the slopes are the same. The only thing that's different between these two lines is that they have a different y-intercept. Okay, other than that, the slopes are exactly the same. Those two lines will never intersect. Okay, parallel lines never intersect. Make a note of that. Perpendicular lines, on the other hand, have the characteristic that the slope of one is a negative reciprocal of the slope of the other. Okay, slope of one line is the negative reciprocal of the other. So let's take a look at an example there. If you look at these two equations, we got perpendicular lines right there. Whoops. Right there. All right. If I look at the slope of this line, the slope of this line is 2. So if we let M1 is equal to 2, and then we have M2 is equal to, up here we can see it's negative 1/2. These are negative reciprocals of each other. So these two lines are perpendicular. Okay. Write the equation of a line through a point that is parallel and perpendicular to the line 4x minus 2y is equal to 4. First step I want to do is put that in slope-intercept form. If I do that, I get y equals negative 2x minus 2. Okay. That means that the slope of a parallel line is equal to negative 2 because it has to have the same slope. I can then use my point slope form of the equation. Didn't specify here, use the easiest one. Here's my point slope right here, equation for a parallel line, and if I look at those, we can see that they're parallel. Okay. Now, if we look at it and we want to look at perpendicular, we know that we have to be the negative reciprocal here. So if M1 is equal to negative 2, then M2 should equal the negative reciprocal of that is positive 1/2. Okay, so that should be what my slope is there. And again, I can use point slope form of the equation, and a quick graph for those two right there. Again, you can see that my slopes are negative reciprocals of each other. Okay, so those two are important points about perpendicular and parallel lines. Here's some homework. I want you to read again section 4.3. I give you some example problems to practice. I give you some problems right here to practice. Not too bad. A couple word problems at the end. Linear word problems. Make sure that you're checking those out. These two sites on Wolfram Demonstrations are very good if you want some visualizations about lines, slopes, y-intercepts. Check these out. It's a good site. These are good demonstrations. Okay. Again, questions you need to email me. Just to wrap up, we looked at different equations of a line. We looked at slope-intercept and point slope particularly. We looked at how to calculate slope, and then we looked at parallel and perpendicular lines. Did a few examples. All right, so hopefully this is mostly review for you guys, and these practice problems will help, and then we'll get ready to move on to functions in the next video. Have a good day.